This is a Bluetooth beacon. I mean, our team built for this project. Their receivers right there in the blue. But I just fixed it up because the charge board right here stopped working. You see the charge and the dun light are like both on. But I don't know. I thoroughly tested it, didn't know what was wrong. And I got to make this work like today. So I threw together this little resistor bank just to make a simple voltage divider to solve the charging solution. So basically, the charger wasn't working, but I have 5 volts and I have a 3.7 lithium-ion battery with, built-in charge, stuff that keeps it from hurting itself. It's quite small. So I'm just going to record this so I remember what I did. So before, this is the USB port. It's a C adapter. And here's the battery in series with the ESP, which works fine. ESP can handle 3.7 volts. It only needs 3.3 to turn on. And there's an on-off switch and a capacitor. And then I put this 2.1 ohm resistor in series with this 5 volt source. So the 5 volts actually puts 5 volts over the battery, which would normally probably cook it, because I don't think there's any kind of current regulation stuff in the battery. But I put this 2.1 ohm resistor here, and that actually loses 1.8 volts over the resistor, and that results in a 600 milliamp current, which is perfect for charging it. So actually it works all right, and it only dissipates 0.7 watts of heat, which is not very much. So yeah, and you can see if I turn the ESP on right here, turns on just fine, turns off. And Alex printed these little clasps, so you can put the whole thing in a box and you just twist the top on. Eismany. Looks nice. I have to drill a hole for the LED, so. So the charge time actually isn't too bad. If the system is delivering roughly either 800 milliamps or 400 milliamps, that correlates to 2.2 watts or 1.8 watts or 1.8 joules per second. And the battery is a 2000 milliamp hour battery at 3.7 volts, so that's 7 watt hours, 7.4 watt hours, which is roughly 27 kilojoules, which is incredible that you can fit 27,000 joules into a little battery like this. Amazing. Anyhow, I made a supercapacitor bank in an old video, and that held the same amount of joules, and it's probably 20 times bigger than this. I mean, covered up like probably foot by foot. Anyhow, so if we assume an average charge rate of 2.2 watts, if we average those 2 wattages at the high and the low, and we assume 27 kilojoules, and we can pour 2.2 joules into the bucket at a time, every second, and we're looking at about 3.4 hours to fully charge it from zero, probably less. So interesting. Actually, the voltage divider works really well, because when you first turn it on, the battery voltage is lower, so the current draw is actually higher, so it charges faster the more depleted it is, and as the battery voltage comes up, the current goes down, it charges slower and slower. Interesting. Very interesting. Anyways, hope this Bluetooth beacon, get that working. Oh God. Don't burst into flames now. Yes, you. So this is just recording the distance between the blue box and the black box. And you can see it's a little unreliable, but if I move it far away, the distance will go up. If I move close to it, it will go back down. So it does work, so that's really good. And holy smokes, did I write the capacitor like that? Sorry, I just went back and watched the video and it gave me pain. What in tarnation? Ah, that's better.